In this video, I am going to solve three problems from chapter 25, Capacitance, from the book Principles of Physics, 10th edition. First question. In figure, find the equivalent capacitance of the combination. So you have to see this figure. In this figure, three capacitors are connected and each capacitor has its own value. So what is the value of the first capacitor? The first capacitor C1 value is 10 microfarad and the second capacitor value is 8 microfarad and the third capacitor's value is 4 microfarad, and you know the value for the micro, which is 10 multiplied by 10 power minus 6 farad, and the second one is 8 multiplied by 10 power minus 6 farad, and the third one is 4 multiplied by 10 power minus 6 farad. Clear? Now we are going to find the equivalent capacitance of these three combinations, because the three capacitors are connected in the circuit. So what you have to do, first of all, you have to identify what are the capacitors connected in parallel or series. Clear? So if you see this figure, capacitors 1 and 2 are connected in series, right? So if two are connected in series, first of all, we have to find the equivalent capacitance for that combination. And if you saw the third capacitor, after you identify the equivalent capacitance for the C1 and C2, then we have to take these three into our consideration. Understand? And we already studied the rule for the capacitors in parallel and series in the theory class. Am I right? We already studied the rule. Am I right? So now we are going to use this rule in this problem for finding the equivalent capacitance. Clear? So what I'm going to do, first I'm going to consider the capacitors, two capacitors, so C1 and C2 here. When you see this figure, you can easily identify. So these C1 and C2 are connected in series, right? So I'm going to use the rule for the capacitors in series. So let's start one by one. So in this figure, C1 and C2 are connected in series, right? Now I'm going to use the rule for the series. What is the rule for the series? 1 over equivalent capacitance or total capacitance. Both are same. Clear? So 1 over equivalent capacitance for the capacitor 1 and 2. Clear? So what's the rule? 1 over C1 plus 1 over C2. This is the rule, because here we are using this rule only for these two capacitors, because these two are connected in series. Your third capacitor is not in series, am I right? So it is in the different combination. But here the two are exactly in series. That's what we are going to find the value of the equivalent capacitance for these two capacitors. Clear? Now we have to modify this equation. So if you modify it, what you'll get? 1 over C equivalent capacitance or total capacitance, which is equal to, you have to take the common LCM, C1, C2. So in the numerator, what you will get? In the numerator, you will get C2 plus C1. Am I right? Right? So okay, now what I'm going to do? I'm going to leave this equation as it is. And if you want to convert, because you have to see the third capacitor, so what I'm going to do, I'm going to convert this 1 over C equivalent, that means 1 over C total, in terms of C total. So what I'm going to do, I'm going to take the reciprocal, because we need the equivalent capacitance. No need to, we are not going to calculate the 1 over equivalent. Am I right? So I'm going to convert this equation in terms of equivalent capacitors. So what you will get? Therefore, the C equivalent for capacitor 1 and 2, which is equal to, it's a reciprocal, right? So C1 C2 over C2 plus C1. So why I just change? Because in the question they ask you to calculate only the equivalent capacitance, not 1 over C equivalent. Am I right? So now what I'm going to do, I'm going to see this diagram better. I'm going to draw this diagram for our easiest consideration. Am I right? So we have the circuit like this, and now we already calculated the value of the equivalent capacitance for C1 and C2. Now what I'm going to do, I'm going to draw this diagram. So this is our equivalent capacitance because we already found the value, because I combined this C1 and C2 together. So here we have the third capacitor here. Am I right? Right? Okay. Now what is this? This is the C equivalent for capacitor C1 and C2. And this is our third capacitor. Now if you saw this figure, this combination and the third capacitors are exactly in parallel. Am I right? So after we find the value for the C equivalent for the capacitor 1 and 2, now we have to compare that equation with the third capacitor. So if you saw this equation, if you saw the figure, these two capacitors, that means the combination of C1 and C2 and the capacitor C3 are exactly in parallel. So now what I'm going to do, I'm going to use the rule for parallel. So what is the equation for the parallel? The equivalent capacitance, for the combination, I'm going to find. So what I'm going to do here, C equivalent, that means C1 and C2 and C3 are in parallel. So if it is in parallel, we have to use the rule. So what is the rule? C equivalent for the complete combination. Complete means here I'm meaning the combination of all three, which is equal to C equivalent of C1 and C2 plus C3, because we have to add. If it is in parallel, we have to add. Am I right? So I'm going to use the value of equivalent capacitance for C1 and C2. What is the answer? What we got in the first part? The C equivalent for capacitance 1 and 2. We got this one. Am I right? So I'm going to take this equation here, which is equal to the C equivalent capacitance for C1 and C2 we got in the previous steps as C1 C2 over C1 plus C2 plus C3. That's it. Now we are going to substitute the value. What are the values we have in the question? C1, C2, C3, all three have a different values. Am I right? So I'm going to substitute this value. C1 10 microfarad, C2 8 microfarad, and C3 4 microfarad. So I'm going to substitute these values in this equation. So what you will get, which is equal to C1 10 microfarad, right? So 10 multiplied by 10 power minus 6 multiply with C2. What is the value of C2? 8 microfarad. 8 multiplied by 10 power minus 6 divided by 10 multiplied by 10 power minus 6 plus 8 multiplied by 10 power minus 6 plus our third capacitor is 4 microfarad, right? So 4 multiplied by 10 power minus 6. Now you have to calculate very carefully. So if you made a small mistakes, our total effort will be waste, right? So please do your calculation very carefully. So I'm going to calculate 10 multiplied by 10 power minus 6 multiply with 8 10 power minus 6 divided by 10 multiplied by 10 power minus 6 plus 8 multiplied by 10 power minus 6 plus 4 multiplied by 10 power minus 6. I got the value as 8.44 multiplied by 10 power minus 6. What's the value? 8.44 multiplied by 10 power minus 6, and the unit for the capacitance. That means this is our C equivalent for the complete three combination. That means three capacitors we have. So for the total circuit, if you saw the circuit diagram, now this is the answer for the equivalent capacitance value for the three capacitors value. Clear? So in this way, you have to apply the rule very carefully, and please find the answer carefully. Okay. So this is the way. So the answer for the last answer for this question is 8.44 multiplied by 10 power minus 6 farad. Clear? Okay. Now we have to move to the second question. Okay. Second question has 5 subdivisions. So you have to answer one by one very carefully because there are different values are given. So let's read the question line by line and word by word. Okay. A parallel plate air-filled capacitors having an area of 40 centimeters square and the plate spacing value is 1 millimeter. That means the area of the plate is given, right? So what is the area of the plate? 40 centimeter. So better I'm going to write the given first. So the area of the parallel, that means what is the meaning for air fill? In between the two plates, I think you already know the diagram for the capacitors. So the capacitors are the two conducting plates which should be separated with small distance d. Actually this is the distance, am I right? So the distance should be a d, and here these two plates are conducting plates where you can store the charge positive and negative. Clear? That means here the value of the area of the plates are given. What is the value of the plates area? The value of the area is 10 centimeter square. So 10 centimeter square, and if you convert in terms of meters, so 40 centimeter square. So if you convert this centimeter square in terms of meter, because we already studied, am I right? So 1 centimeter, which is equal to 10 power minus 2 meter, and we have square here. So if you're squaring this left hand side and right hand side, so 1 centimeter whole square, which is equal to 10 power minus 2 meter square. Value for 1 centimeter, because 1 square is 1, so the 1 centimeter is equal to 10 power minus 4 meter square. So what's the value here? Multiply by 10 power minus 4 meter square. Clear? And the space between the two plates d value is already given, am I right? So the value for the spacing between the plate is given as 1 millimeter, which is 1 multiplied by 10 power minus 3 meter, because I converted this millimeter in terms of meter. Clear? 1 millimeter, which is equal to 10 power minus 3 meter, right? And these capacitors, for this capacitor, we give the potential difference of 500. So how much potential difference we give? The potential difference V here is 500 volt. Clear? Now by using these values, what are the things we are going to find? In the first part of the question, we are going to find what should be the capacitance. And we studied the formula already, am I right? What is the formula for the capacitance for the parallel plate capacitor? The parallel plate capacitor formula is, for the first question, what's the formula for the parallel plate capacitor? Capacitance, which is equal to area multiplied by epsilon naught divided by the space between the two plates. And we have all the values. So now what I'm going to do, I'm going to substitute the value one by one. So what are the values we have? The area of the parallel plate capacitors is given as 40 centimeter square, which is 40 multiplied by 10 power minus 4 meter square, multiplied by, what's the value of the epsilon naught? Permittivity of the free space, which is 8.85 multiplied by 10 power minus 12 Coulomb square over Newton meter square. That's the value for the epsilon naught. So better I will write one more time. So the epsilon naught value is a constant, 8.85 multiplied by 10 power minus 12 Coulomb square over Newton meter square. So the value of the epsilon naught I am going to substitute here. So 8.85 multiplied by 10 power minus 12, right, over, and the d's, what is the distance between the two plates? It's 1 millimeter. So 1 multiplied by 10 power minus 3 meter. So now when you calculate all these things, you will get the value for the capacitance of the parallel plate capacitor, right? So now I'm going to calculate 40 multiplied by 10 power minus 4 multiplied by 8.85 10 power minus 12 divided by 1 multiplied by 10 power minus 3. I got the answer as 3.54. What's the answer? The answer for the first question is 3.54 multiplied by 10 power minus 11. And what's the unit for the capacitors? The capacitance unit is farad. Clear? So this is the answer for the first question, because this question has 5 subdivision. Am I right? So this is the answer for our first part. Now in the second part, what we are going to calculate, we are going to calculate the magnitude of the charge on each plate. So what I told you before, because these two plates are the conducting plates where you can store a positive charge and the negative charge. So what they ask in the second part, we are going to find what should be the charge on each plate. And we know the capacitance formula, am I right? So what is the formula for the capacitance? We already studied this formula in the theory. To find the charge in each plate, what is the rule? Q, which is equal to CV, because we already studied the capacitance, C, which is equal to Q over V. Am I right? So this rule we studied in the theory. Am I right? So if you rearrange, if you remodify this equation in terms of charge, we got charge Q, which is equal to C multiplied by V, and where C value we already found in the first part. So what I'm going to do, I'm going to take this answer, I'm going to substitute here, and the potential we already gave in the question. What's the value of the potential? 500 volt. Am I right? So what I'm going to do, I'm going to substitute the value. So for the capacitance value, I'm going to take the answer from the first part. In the first part, we got 3.54 multiplied by 10 power minus 11, and the volt we gave here is 500 volt, right? So when you multiply this capacitance with the volt, you got the answer for the charge. So 3.54 multiplied by 10 power 11, 10 power minus 11 multiplied by 500, I got the answer as 1.77, 10 power minus 8. 1.77 multiplied by 10 power minus 8. And what's the unit for the charge? It's coulomb. Am I right? So the unit for the charge is coulomb. So this is the answer for the second part. That means second subdivision. And what is our third question? Find the stored charge. So how much charge stored in the plate we already found. So now we are going to find what should be stored energy, not charge, stored energy. So we have 3 rules, am I right? So what are the 3 rules we have? So better I will write one by one and we will get the same answer. You can use any one of these formulas. What are the formulas we studied in the theory? The stored energy, which is U, caps U, which is equal to half multiplied by CV square. And we have one more rule, U, which is equal to Q square over 2 multiplied by C, and also we have one more rule, U, which is equal to half multiplied by Q multiplied by V, right? So better I will do one thing. In this place of Q, I am going to use small q. So you have 3 rules, am I right? You can use any one of that. You'll get the same answer. You can use any one of the equations, you'll get the same answer. Better for this calculation, I'm going to explain with the 3 equations. So anyhow, we are going to get the same answer. Let's start with the first equation. What is the answer? U, which is equal to half multiplied by, and the capacitance we got in the first part as 3.54, am I right? So 3.54 multiplied by 10 power minus 11, and the volt is 500, am I right? So that means 500 square. What's the answer? We will just go one by one, but anyhow we are going to get the same answer. So in the exam you can use any one of this rule. Okay, so what's the answer? 1 over 2 multiplied by 3.54 10 power minus 11 multiplied by 500 square. So we got the answer as 4.425. So better I write 4.43. So what's the answer here? 4.43 multiplied by 10 power minus 6. 10 power minus 6, and this is the energy. So what's the unit for the energy? Joules. Clear? And if you use the second rule or third rule, you'll get the same answer, but better I'm going to calculate one by one. So here U, which is equal to charge in the first part, the second question, what's the value of the charge? We found 1.77 10 power minus 8. Am I right? So I'm going to use this value. So 1.77 1.77 multiplied by 10 power minus 8 the whole square over 2 multiplied by capacitance value I am going to take from the first part, which is 3.54 multiplied by 10 power minus 11. So 2 multiplied by 3.54 multiplied by 10 power minus 11. So now I'm going to calculate what should be the answer. For sure it will be 4.43 multiplied by 10 power minus 6, but anyhow we will find the answer as 1.77 10 power minus 8 the whole square over 2 multiplied by 3.54 multiplied by 10 power minus 11. Yeah, we got the same answer. 4.425, which is 4.43. 4.43 10 power minus 6 joules. Let's we do the same thing for the third rule. Better, it's the easiest way, am I right? So third rule, half multiplied by the charge value I'm going to take from the second part of our question, which is 1.77 multiplied by 10 power minus 8. So 1.77 multiplied by 10 power minus 8, and the voltage, the potential difference is 500, right? So let's we calculate for this also. So calculate half multiplied by 1.77 10 power minus 8 multiplied by the voltage 500. We got the same answer, 4.43 multiplied by 10 power minus 6 joules. So you can use any one of the rule, either half CV square or U square over 2C or half multiplied by Q multiplied by V. You can use any one of these three. You will get the same answer. Okay. Okay. Now we have to move to the fourth part of the question. What is given in the fourth question? We are going to find what should be the electric field between the plates. What should be the electrical field, brother? You have to see this diagram. So if you have two conducting plates, so we can easily find what should be the electrical field between the plates. How we can calculate? Because we studied the rule, voltage which is equal to electrical field multiplied by the distance. Am I right? In chapter number 24, when you study the potential formula, right? So if you want to find what should be the electrical field here, you can use the same rule, but you have to rearrange this equation in terms of electrical field. What's the rule? E, which is equal to V over D. This is the rule. So I'm going to use this rule for the fourth part of the question. Okay. So we are going to calculate what should be the electrical field. So in the fourth part, that is D. Am I right? So electrical field, which is equal to potential over the distance between the two plates. What is the potential? The potential we gave here as 500 volt, and the spacing between the two plates is exactly 1 millimeter, which is 1 multiplied by 10 power minus 3, right? And this 10 to the power of minus 3, when it go to the numerator, it becomes a plus 10 to the power of plus 3, right? So we got the answer here as electrical field E, which is equal to 5 multiplied by 10 power plus 5, right? And what's the unit for this electrical field? Because we have different units, am I right? So for this equation, the unit is exactly volt over meter, because we are using the unit for the voltage is volt and the unit for the distance is meter. So the unit here is volt over meter. Clear? So this is the answer for the fourth part. Now we have to go for our last question. So in the last question, what we are going to find the energy density between the plates. Don't get confused about the third part as well as the fifth part. Okay, in the third part we found the stored energy, but here it is the energy density. Clear? And energy density also we have three rules. Am I right? So you can use any one of the rules, but better I can write here. Let's see, because when we use these two equations, 2 or 3, am I right? So the third, fifth part, energy density. In theory we studied energy density, which is equal to stored energy over volume. Am I right? Am I right or not? And you can write this volume as energy over area multiplied by distance, because in the question the volume is not given. Am I right? So I can write this volume in terms of area multiplied by distance, because area unit is meter square and the distance unit is meter. When you just combine these, you will get meter cube. So the meter cube is the unit for the volume. So either you can use this rule, or energy density, which is equal to, what's the another formula? In theory we studied. I think electric field square, right? Electric field square multiplied by the epsilon naught over 2. Here epsilon naught is the permittivity of the free space. So either you can use this part or this part. You'll get the same answer, but in this for this question I'm going to use two equation. Let's be confirm, am I right, whether our answer is right or not, am I right? So what is our energy? In the previous part we found the energy, I think in the third part, am I right? So we got the energy as 4.43 multiplied by 10 power minus 6. So I'm going to use this value here. So what's the answer for this energy? 4.43 multiplied by 10 power minus 6, right? Divided by, what is the area of the plate? They mentioned 40 centimeter, am I right? The area of the plate is 40 centimeter square. So which is 40 multiplied by 10 power minus 4 meter square. I'm going to use this value here. So 40 multiplied by 10 power minus 4 multiplied by, what is the distance between the two plates? It's 1 millimeter, am I right? So the distance between the two plates is 1 millimeter, which is 1 multiplied by 10 power minus 3 meter, am I right? So 1 multiplied by 10 power minus 3. So let's recalculate. So it's a small u, it's not caps u, because caps u is the energy, small u is the energy density, which is energy per unit volume. The formula, the definition is, the energy density is nothing but energy per unit volume. So 4.43 multiplied by 10 power minus 6 over 40 multiplied by 10 power minus 4 multiplied by 1 10 power minus 3. I got the answer as 1.0175, right? So better I can write, I got 1.1075. So I can write 1.11, right? 1.11. What's the unit? I said energy over volume, am I right? So energy unit is joules and the volume is meter cube, right? Okay, let's use the second equation, because if you are using this you will get the same answer. And we have the electric field also in the previous question, am I right? What's the value of the electrical field? Which is 5 multiplied by 10 power plus 5, am I right? So 5 multiplied by 10 power plus 5, and epsilon naught, it's a constant, am I right? We are, because we used this equation in the first part of this question, am I right? 8 by 10 power Coulomb square over meter square over, so I'm going to calculate 5 10 power 5 multiplied by 8.85 10 power minus 12 over 2. Oh, sorry, this is square, am I right? I forgot the square. Okay, so better I can use the square here. Yeah, exactly the same answer. So I got the value as 1.11. So if you substitute the unit for electrical field or the epsilon naught, you get the unit as joules over meter cube. So this is the answer for the last question. So we have 5 subdivisions, and for these 5 subdivisions we already found the answer. Clear? Please write the rule correctly, and then please while you calculate by using your calculator properly. Clear? If you made a small mistake in the first part, what will happen? Your second part will be wrong. If the second part will be wrong, your third part will be wrong. Am I right? And if your third is wrong, all right, and the last will be wrong, because the electrical field we are using the volt over distance, which is already given in the question. So it's very easy. But the part A, B, C will affect the answer. Am I right? For the last part, E also. Am I right? So please do your calculation properly. And now we are going to solve the last question. What is given in the last question? A coaxial cable used in the transmission line has an inner radius of 0.1 millimeter and the outer radius of 0.4 millimeter. So it's a coaxial cable. We are using these type of cables in our day-to-day life applications. Am I right? So this cable has two layers. Am I right? Which I can draw the diagram. It will be a cable over a cable. Am I right? So if you just consider this is the outer layer and the inner layer, we have this type of wire we have for different applications. Am I right? Okay, this is the coaxial cable. And from the center to the outside, it's the outer layer, outer radius. Am I right? Likewise, for the inner layer, this is our inner radius. Am I right? So this is our inner radius, right? And this black color line is the outer radius. I think I can write R2 for the outer radius and R1 for the inner radius. Clear? Okay. Calculate the capacitance per meter. So what you are going to calculate? We are going to calculate what should be the value of C over L, because the unit for the length is meter. So they just said calculate the capacitance over meter. So we are going to calculate the value of C over L. Okay. Assume that the space between the conductors, which conductor? This cable, okay, is filled with epoxy resin with a dielectric constant 3.6, because the dielectric constant value is the unitless, and each some materials, actually this dielectric constant, yeah, the dielectric materials have a unitless value. We have different types of dielectric material. So you, in this question they are using epoxy resin, and that material have the dielectric constant value of 3.6. Actually, where they kept this material in between the two layers, right? Better I can just use, actually the epoxy material will be here. I can use, so epoxy material will be here. Clear? And this epoxy material has the constant value of 3.6. So now we have to use the rule. Actually, in theory, we studied this in terms of cylindrical capacitor. Am I right? So for this question, I'm going to use the formula for the cylindrical capacitor. What's the rule we studied in the theory, brother? We studied the rule of the cylindrical capacitor is capacitance of the cylindrical capacitor value, which is equal to 2 pi, right? 2 pi epsilon naught L over natural log of R2 over R1. So this is the rule we studied, am I right? For the cylindrical capacitor. I'm going to use the same. But the most important thing, brother, we already studied in the theory, am I right? If you have the dielectric materials, you have to multiply with K. Clear? So here we have the formula for the cylindrical capacitor is 2 pi epsilon naught L over natural log of R2 over R1. But here we have the dielectric constant. So we have to multiply with this K in front of this equation. Clear? Okay. And the second important thing, in this question, we are not going to find the capacitance value. We are going to find the value of capacitance over meter. So if you want to get C over L, what you have to do, you have to take this L to the left hand side of the denominator, right? So I'm going to take this, I'm going to move this L to this. So by that the equation will become C over L, which is equal to, correct, K multiplied by 2 pi epsilon naught over natural log of R2 over R1. Now we have all the values. So better I will write the values which is given here, and the inner radius, that means R1 value is 0.1 millimeter. I can write the value that given here. R1 is 0.1 millimeter, which is 0.1 multiplied by 10 power minus 3 meter, and the value of R2 is, I think they mentioned 4, am I right? 0.4 millimeter. So the value of the R2 is 0.4 millimeter, which is 0.4 10 power minus 3 meter. That's not a matter, because when you divide this 10 power minus 3, whether you are using the value in terms of meter or millimeter, that will be cancel each other. Am I right? But for just because we have to recall something, millimeter conversion to meter, we are using, am I right, this 10 power. That's the reason I just wrote it here. Otherwise, if you are using the millimeter directly here, no issue, because we are going to find the value of C over L. Am I right? And what's the value of the K value? K, the dielectric constant for the epoxy resin is 3.6, right? So now what I'm going to do, I'm going to substitute. And the epsilon naught is the constant. What's the value of the epsilon naught? Which is 8.85 multiplied by 10 power minus 12 coulomb square over Newton meter square. So now I'm going to substitute the value for getting the value of capacitance over meter. So C over L, which is equal to 3.6 multiply with the 2 pi multiply with 8.85 multiply by 10 power minus 12 over the natural log of outer radius over inner radius. What is our outer radius? So 0.4 multiplied by 10 power minus 3 over 0.1 multiplied by 10 power minus 3. So let's see what answer we are going to get for this capacitance over meter. So capacitance over meter is nothing but C over L, which is equal to, let's see what's the answer for this. So 3.6 multiplied by 2 multiplied by pi multiplied by 8.85 10 power minus 12 over natural log of 0.4 10 power minus 3 over 0.1 10 power minus 3. So I got the answer as 1.44 multiplied by 10 power minus 10. So 1.44 multiplied by 10 power minus 10. And what is the unit? The unit for the capacitance is farad, and the unit for the length is meter. So what's the unit for this capacitance over meter? Which is farad over meter. Clear? So this is the answer for the last question. Clear? Clear? The most important thing, please keep all the formulas in your mind. Otherwise, it's really very hard to solve. Clear? That's it. Thank you.